Okay, this video is to help with section 9.5 day 2, questions number 7 and 8. I'm actually going to do both of them because they're related. All right, we're trying to find the sum of this series, all right? And at first it looks like it's infinite because of this dot, 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 dot. So you'd be think maybe I'm going to use my infinite formula, but if it's actually 7 terms long, then it's actually not infinite. It's a finite thing. It ends at the 7th term over here. Right? So one thing is you could actually just extend the pattern. I think this is going up by 2.5. So you could actually just extend the pattern to find all 7 terms and then add them all up. That'd be one way to do it. But if you want to get more practice with the formulas, right? Because if this said, evaluate the series for 100 terms, I don't want to list all 100 out. That's going to take me forever, right? So again, you got to figure out which formula to use. And the best thing I can give you is this formula sheet, right? So we have an arithmetic pattern because it's going up by 2.5, and it is, let's see, it's finite because it ends, right? If it was infinite, it actually wouldn't have a sum. So this is a finite arithmetic, so we want to use this little formula. Okay, and then as far as actually finding the sum, so the sum of 7 terms, n is 7, and then the first and last value. So the first term is 12.5, and it looks like the fact I extended it out here, I actually know the last term. So that's going to be 27.5. All right, and then I just gotta do the math to figure it out. So 7 divided by 2 is 3.5. Add those two together. I believe that comes out to be exactly 40. You might want to check my math there. And so let's see, 3.5 times 40, 340s would be 120, plus half of 40 would be 140, I think should be right. Right? You might want to again check that, but I think that should be okay. All right, so this one should be 140. All right, and then question 8. Very, very similar. All right, this pattern is going down by 5 each time, which makes it arithmetic. And it's a series because we want to add them all up for 11 terms. So it's kind of the same formula. All right, I would say what's different on this one is we don't necessarily know a sub n, the last value. Right, so if I did my little setup here, I could say the sum of 11 terms is 11 divided by 2. I certainly know the first term, that's negative 100. But I don't know what is that last term a sub n. Certainly we could list them all out, all right, but I think it would actually be easier if we said, okay, what is the 11th value over here? So basically, if we had the explicit formula, we could make n be 11 and then find the a sub n value. Remember, these are n and these are the values a sub n. Okay, so the formula for an arithmetic sequence is it's the first term plus d times n minus 1, where d is the common difference. So for this particular problem, a1 is negative 100, and we're going down 5, so d is minus 5. Okay, and then oftentimes we clean up this formula. So negative 100 minus 5n plus 5n, sorry, plus 5 when you distribute the negative 5. And now we can combine the negative 100 and the positive 5. So we get negative 95 minus 5n. All right, and so we want to know n is 11, what is a sub n? So, oh man, Mr. Westphal messed this up though. This is actually going up 5, not down 5. Not good. All right, at any rate then, that would just make this be positive 5. And so I think I can still edit this. So this would be plus 5n, and then this would be a minus 5 here. Okay, let's see if we can actually do this right. So if we changed all that and cleaned it up, it would be negative 105 plus 5n. Okay, now that we got the right formula, now I find the 11th term. So negative 105 plus 5 times 11. Just make n 11 and figure that out. So negative 105 plus 55. And I think that should come out to be negative 50. If I did that right. All right, and so that's going to be the 11th value. So n of 11 yields a term of 50, negative 50. So plug that in as our last term, and now it's just crunch away. So the sum, not surprisingly, is going to be negative here. 5.5 times negative 150, right? And then crunch that away on your calculator. All right, and when you type it in, negative 825. It's always good to think, does that seem reasonable? Right? If you imagined all of these negative numbers being added together, it seems reasonable the sum would be negative 825. All right, hope that helps. Keep the questions coming.